In this video, we will find out how to write a reflection rule and how to perform more complicated reflections. In my previous video, we talked about how to reflect a shape if you're just given its line of reflection. First, you draw that line of reflection, you count how far each point of the pre-image is from the line of reflection, and then put each new point of the image the same distance but in the opposite direction. And then you connect all the dots to make the picture, to make the shape. So now we have done some reflections over the X and Y axes, and we're going to find out what happens to their coordinates because we might be able to figure out a rule that we could just do mathematically rather than having to draw everything out to figure out the way it is. So on our X-axis, I'm going to look at the coordinates of the pre-image. That's the original shape or the no primes shape. So A, it's -2, 1. B is, the X coordinate is 1, and then the Y coordinate is 3. C is 2, and then it goes down below the X-axis, so it's going to be -1 for Y. And then D, that's this one over here, is going to be -1, -2. Okay, let's make sure I got all those coordinates correct. A is -2, 1, B is 1, 3, C is 2, -1, and then D is -1, -2. Okay, so now you go ahead and write what you think the coordinates are for A prime, B prime, C prime, and D prime. You might notice a pattern. Okay, here's what I got. A prime is -2, -1. B prime is 1, -3. C prime is 2, 1. And then D prime is -1, 2. Okay, so what pattern did you notice? Now, all these numbers look pretty much the same. They look pretty much the same. There's just one key difference. As you look from A to A prime, the only thing that changed was that this one became negative right there. And then from B to B prime, that 3 became negative. And then C to C prime, that 1 became negative. And then D, it was negative before, and now it's not. So how do we write that? Well, the X coordinate stays the same, so that X will be the same number. So we can say that XY goes to X, comma, and we got to figure out what Y is. Y will end up being the same actual number, but it's the opposite. It's the opposite of if it were negative, it's now positive. If it was positive, it's now negative. Now, to write the opposite of a number, how do you do that? Well, you write that number and then you write a negative sign. So this looks like it's always going to be negative, but what it really means is whatever Y was, you're going to find the opposite of that, or you're going to multiply it by -1. And remember, if you multiply a negative number times -1, you get a positive number. So our rule for this reflection is that XY goes to X -Y. And this will actually be the rule always when we reflect over the X-axis. It will always just change the Y coordinate and make it the opposite. So it might be helpful to remember that or to have it in your brain that you just swap which way the Y coordinate is when you reflect over the X-axis. So now we're going to look at our shapes and just think about the angle measures on the shapes. So when you look at the angle measure of C compared to C to C prime, does it look like it's the same measure? And then D compared to D prime. It looks, these ones are all like really close to 90 degrees, but it looks like they're all going to be the same. So I'm going to circle same. And then the size of these shapes, it doesn't look like it's growing bigger or smaller, so I think that's also the same as well. Orientation is a fancy word that means which way the shape is facing. It actually talks specifically about like when you look at C, if I were a person and I were C, B is on my right and D is on my left. Now when we look at C prime, if C prime is a person, B prime now swapped directions from it. It's on its left and on its right. So all of the directions of where everything is. It's just like in the mirror, how my part is on the left side of my hair, and then my mirror image, their part is on the right side of their hair. If you've ever done like FaceTime or something like that, you notice how it always looks slightly weird because it's actually your mirror image. So that is, that's what the mirror image is. It changes the orientation. So this is different. And then even though the orientation is different, because the angle measures are the same and the size is the same, and these are the same shape, these shapes are congruent. They are the same shape and the same size. And the orientation, although it's different and important to know that it's different, that doesn't affect these shapes have earned the status of being congruent. So now let's look at this y-axis. Let's put our pre-image coordinates for A. I get 2, 3. And then B, it's over there. Look at the black one. -1, 1. And C is 2, -2. Now go ahead and write what you think the coordinates are for A prime, B prime, and C prime. Pause the video. Okay, so A prime, I get -2, 3. B prime, I get 1, 1. For C prime, I get -2, -2. Now this one, same thing happens, just one thing changes. We just have this time it's the x coordinate. So, and it changed to be the opposite. So to say the opposite of x, we say -x. And then y stayed the same, so that will be our rule. And when we compare the angle measures, looks like these ones are going to be the same too. C versus C, D versus D. So these are the same, and the size of the shapes is the same. The orientation over here, if we look at B, A is on B's right. If we look over here, B prime's right. And then over here, A is on B's left. So our orientation is different. And it turns out that this will always be the same, that a reflection will always have the same shape and the same size, and it will always be congruent, but the orientation will be opposite. Okay, so now we have some tough ones to do. We're going to go over here and we're going to reflect over some lines that are a little bit tougher. So we're going to reflect over the line y equals x. And it may be helpful to remember that the slope when there is no number in front of x is going to be 1. And it's going to have y equals 1x plus 0. When we graphed lines, we used the equation y equals mx plus b. And so 0 is where it crosses at the y-axis. And then 1 is the slope, and that means it goes up 1, right 1. Because it's change in y over change in x. 1 over 1. Now, you can also just know that it's the point, it is the line where all the coordinates on that line are going to be identical. Like this is 1, 1, and this is 2, 2, because y equals x. So there's our line. We drew it. Now we need to reflect over that line, and this part's going to be a little hard because we're going to be working with diagonals. So now I need it to be in the opposite direction. So B, we have this nifty line that B is on. So B is one square diagonal. So my new B, I'm going to do this in red, is going to be 1 square diagonal the other way. And same thing with C, it's 2 squares diagonal, so my new C prime is going to be this way. Okay, so there's my B prime, C prime, but how do I figure out A? Maybe we'll do a little line diagonal. It's half a square, so our A prime is going to be over here. And then let's draw our new triangle, the image. So that was tough. So this one, it might actually be really, really useful to know what the rule is. So let's go ahead and find our pre-image coordinates and our image coordinates. I'm going to let you go ahead and find those on your own, and I'm going to fill it in. Pause the video, find out what your pre-image coordinates and your image coordinates are. All right, so A was 2, 3. Wait a minute, I think this is the same triangle as before. Hey, what do you know? It is. So it's 2, 3, negative 1, 1, and 2, negative 2. Okay, I think that's the same on this other one. I'm just going to go ahead and save some time here. We used the same pre-image on 3 of these examples, so I'm just going to write that in there. Okay, so then our A prime is going to be 3, 2. And B prime is 1, negative 1. And C prime is negative 2, 2. Now, what do you notice changed from here to here about those numbers? They swapped locations. So I think it's kind of weird because, like, how do you write that? Because you can't just be like this and your transformation rule. That doesn't make any sense. Well, we want the numbers to switch, and x represents whatever number x is. So on our first one, x is 2 and y is 3. Well, to say that we want it to be 3, 2, we're just going to swap x and y. We're going to write it like this. xy becomes yx. So our new x coordinate is our old y coordinate. So that might be helpful to use, especially if you're told to do reflect over y equals x, and it's really hard to visualize reflecting over y equals x. You now know that all you have to do is swap the coordinates. And this is going to be the same as before. Same angle measures, same size, different orientation. Let's actually check that. A prime is on B's right, and A is on B's left. So the orientation is different. These shapes are still congruent. So basically, you should know that those are always going to be the same. If you find that the orientation is the same, then you did the reflection incorrectly. If you find that the shapes are different sizes, you did the reflection incorrectly. Okay, now one more, and this one's the hardest one. Our y equals negative x line is going to be with a negative slope going through the origin. So it's going to go like this. Now I'm going to actually talk you through that a little bit slower. This is a negative 1 slope with a 0 y-intercept. So it goes down 1 and right 1. It goes down as you read from left to right. And it looks almost exactly the same as y equals x. So that's how you draw that line of reflection. Now let's go ahead and draw our A prime, B prime, and C prime. Here, this is nice. B prime is the same, and C prime will be the same. And A, ooh, that's a little rough. Okay, we're going to draw a line going through A to figure this out. Aren't you glad that we're going to figure out a rule and you don't have to do this anymore? Okay, here's our A prime. We'll be right there. Let's see if I did it correctly. That doesn't look right to me. Okay, I think I did my A prime incorrectly. So we have it. It is there. So actually it's going to be right there. It's going to be 3 and 2 the opposite way. Oh, that looks so much better. Yeah, that looks way better. Doesn't that look like a mirror reflection? Okay, so this one is hard to do. Like, these two are really hard to do on your own. So let's figure out what the transformation rule is. Our B coordinates are the same for negative 1, 1, and our C coordinates are the same, 2, negative 2. Our A coordinates, instead of 2, 3, we now have negative 3, 2. Okay, so how does this change? So it looks like we swapped them. Oh, it's negative 3, negative 2. We swapped them and made them both negative, the opposite. Now, so it's going to be swapped. Y and X are swapped, and then the opposite. So now this rule will work every time you go over the line y equals negative x. You'll have xy arrow, negative y, negative x, and then you can figure out from there. So you could just swap both your x's and y's and make them the opposite, and then you can figure it out. Now, did this actually work on our other points? So our 1 from our y became negative 1. We swapped it and it became opposite. Same here. Okay, swapped it and it became opposite, swapped it. That is so cool. So we didn't have to do anything with those points, but they were following the rule the entire time. So what I would recommend is, particularly on these ones, whenever you have to reflect over y equals x, you should just know that you're going to swap x and y. And then when you reflect over y equals negative x, you're going to swap them and they're both going to become negative.